Good morning. My name is Harish. I work as assistant professor in the Department of Electronics and Communication in Nagarjuna College of Engineering and Technology. Today, I would like to deliver a session on data flow description in HDLs. Okay. So, as we know the importance of HDL, hardware description language, here we write programs to every component, and the writing the style or the description styles in HDL very predominantly used languages are VSDL and Verilog. So both the languages are used as HDL both in research as well as academics. So both VSDL and Verilog has various description styles. They can be data flow description, behavioral description, switch type, mixed language. So out of which we will be dealing with data flow description in today's session. So data flow description simulates the system as a flow of signal from systems input to systems output. As the name indicates, it's a flow of data from input to output. So when we are dealing with this type of description, we need to focus on two elements. The first one, signal assignment, and second, concurrent execution. So signal assignment in the sense, so as in when we define any hardware, we should know the Boolean expression for it. So when we know this Boolean expression, we will relate your inputs according to your outputs. So there is the flow of input signals towards your output signals. So this can be made possible by a symbol less than or equal to, which is used as signal assignment operator in VHDL. In Verilog, we use a pre-defined word called as assign. So in order to write a program in data flow description, if you are writing with VSDL program, you need to use this operator. Only then we can call the description style is data flow. If you are writing with Verilog, you should use the word assign. Only then we can tell the program is in data flow description. Second element that is very important in data flow description is the concurrent execution. So what is this concurrent execution? So concurrent execution refers whenever there is a change in any part of the simulation time, immediately there will be change in your output. This part is called as concurrent execution. Okay, so when we discuss data flow description, two elements. The first is signal assignment, the second is concurrent execution. So we'll see an example of writing a program in both VHDL as well as Verilog to understand more about your data flow description. Let us discuss this data flow description with an example of off adder. As we know, what is an off adder? Off adder is a combinational circuit which has two inputs, two outputs. So I'll be taking A as one input, B as the second input, and two outputs. I'll be taking it as sum and carry. Okay, basically off adder is a combinational circuit which performs addition between two of its input, and it's giving out two outputs. One is the sum, the second is carry. So we should know the truth table. So before we evaluate the output of it, so A, B, there are two inputs and two outputs. So if there are two inputs, we will be having four different combinations. So it starts with 0, 0, 0, 1, 1, 0, 1, 1. So when we add 0, 0, the sum is evaluated 0 and carry is also 0. 0 with 1 will lead to sum as 1 and carry as 0. And 1 added with 0 will fetch you sum as 1 and carry as 0. 1 with 1 will give you sum as 0, carry as 1. So this is the true table for off adder. So from here we can easily evaluate the Boolean expression for your outputs, that is sum as well as carry. So since here it is simple, looking at your true table, your function table, we can evaluate the Boolean function for sum and carry. For sum, it is XOR operation between A and B. So I'll be writing it as A XOR B. For carry, it is AND operation between its inputs. So it is A and B. So if it's more complex, we can make use of K-maps and we can evaluate or we can arrive at the output expression. So once you get your outputs, now we will have to be writing the data flow description. First, we'll write your VSDL code. So any VSDL code has two parts. One is entity, the second is architecture. So entity refers to a part of program where you are declaring your number of inputs with number of your outputs. So that I'll be starting. It starts with a predefined word entity followed by an identifier. To identify this entity, I'll be taking the name as of underscore adder. So this is the name that we can give to entity. And the rules that you need to follow in naming this entity is you can't start an identifier with a numeric. Okay, you can't use 1, 2, 3, no numbers. It should always start with an alphabet. There are more words, you can use a special characters like underscore. Okay, then is used as a predefined word. The second part of your entity is to write the port. This port is again a predefined word where it is used to write all your inputs and outputs of the system. So for off adder, as we discussed, we require two inputs, two outputs. So I'll be naming it as A, comma B. Both are input port type is in and data what I'm following here is 0, 1. So we'll be using bit. Then we need two variables to be declared as outputs. The first one is sum, the second is carry. Both are used as output followed by again the data type of it, that is bit. Now once you declare all your inputs and outputs, now you can end your entity. So end is a predefined word used to end your entity followed by the name of your entity. The name what I've given is of underscore adder. So you can use the same name followed by a semicolon. So this part is the entity. Now once entity is done, we will have to start with the second part, that is architecture. So what is this architecture is, rather than declaring your inputs, your architecture deals by showing the relation that is existing between your inputs and output. That is nothing but your Boolean expression. Okay, so that again starts with a predefined word called as architecture. Again an identifier need to be given to this architecture. I'll be giving it as dfex. It's an user defined, you can give any name. Now once you give an identifier for the architecture, immediately you need to bind one of your entity. Bind is nothing but you are linking one of the entity to this architecture so that your architecture can understand what are all the inputs and outputs that to be included in this architecture. That binding will be done by a predefined word called as of. Okay, this predefined word called as of binds the entity. So I wanted the entity name as off adder need to be linked with this architecture. So I'll be naming that entity here is. So now this architecture which is having a name df underscore ex, that is data flow example, is binded with one of its entity called off adder. Now this architecture can easily look into the entity off adder and can make out A and B are inputs, sum and carry are outputs. Now the second part of your architecture starts with the begin. Now clearly show the data flow description, that is assignment, signal assignment to be appearing in this architecture part. So declare your sum relation by writing signal assignment operator like this. Sum is equal to A XOR B. A XOR B. The second output is carry. Again, the relation between inputs to be related by writing signal assignment operator, and the operator between carry and inputs is AND. A and D, B. Now this is the end of your architecture. Clear, you can write it as end with the same name of architecture, that is TF underscore AX. So this is how where you can write your VHDL code in data flow description. Thank you.